Now we'll solve an interesting problem 21, that is evaluate the xp uncertainty product delta x square delta p square for one dimension particle confined between the two rigid walls. Do this for both the ground and excited state. Here the expectation of sx square and delta p square is over the state which is eigenstate, which is eigenstate of the Hamiltonian operator. So here first we have to check what is the Hamiltonian operator. Hamiltonian operator is H equal to p square by 2m. M is the mass of the particle plus px, and the potential is like that between 0 to 1, 0 to 1 it is 0, and outside the box it is infinity. That means H inside the box is equal to p by 2m, which is 0 x less than a. Now we have to calculate the eigen gates of the Hamiltonian. So we have to calculate this. So suppose that n is an eigengate of this Hamiltonian operator. That means Hn should be some En n. Now let us see what is the position representation of these states. That will be x h n will be En xn. As we know from our previous lecture, this is nothing but it is called the wave function of the state n. It is generally a function of x. So that means, and here let us calculate this. So it is x p square n, and we know from our position, from our momentum, the representation of momentum in position gates, this is nothing but minus I h cut its square into del 2 del x2 xn. That means minus h cut square t2 tx2 fx. Since this partial derivative is replaced by this derivative, because this is only a function of x. So that means the position representation of this will be minus h cut square by 2m t2 tx2 xn. That means minus h cut square by 2m t2 tx2 f of x. Now let us calculate what is the value of this wave function. Minus h cut square by 2m t2 tx2 fx should equal to en fx. So that means t2 tx2 fx should equal to minus 2m en by h cut square fx. So for the solution of this equation will be fx is equal to a cos x, cos, suppose this is this is k square. That means 2m en by h cut square equal to k square. So then fx will be a sin kx plus p cos kx. Now since the particle remains inside the box, because to the boundary of the box, the potential at the boundary of the box is infinity. So that means the particle remain inside the box. That means the wave function. Wave function is nothing but the component, probability component, that the particle will be found at this state x. So the probability of particle finding at this or this region will 0. So that means this wave function should also be 0 at x equal to 0 and x equal to a. So these two boundary conditions should satisfied by this function. So that means f of 0 should be 0, which gives b equal to 0, and f of a should 0. That means a sine ka is equal to 0, which actually means ka should be n pi. The value of k can be calculated from this n pi by a. That means 2 m en by h cut square is equal to n pi by a. N pi by k square, so n pi by k square means this. So en is equal to h cut square, n square h cut square, pi square by 2m h square. So the ground state will be corresponding to n equal to 1, since ground state means the energy En is lowest energy state, that corresponding to n equal to 1, and excited state will be n not equal to 1, and here the value of n could be 1 to infinity. Now let us calculate what is the value of the dispersion, delta dispersion of x position. So x, we have to calculate the expectation of x. Let us see that at first we have to normalize, since the probability to remain inside the box, probability of remaining inside the box is 1. So that means n should be 1, which actually means minus infinity to plus infinity dx n x n should 1. Here we use the completeness relation of the position gates. That means minus infinity to plus infinity dx f star x fx is equal to 1, and we know that this 0 to 1, since fx is 0, only non-zero between 0 to 1, that means fx dx f star x fx should give 1. That means a square mod h square 0 to a sine square n pi x by a, so dx should give 1. That means a square mod a square by 2 0 to a dx, this is 2 sine square x means 1 minus cos 2 n pi x by a is equal to 1. The integration of our cos 2 n pi x by a will be 0. So dx, that means mod a square by 2 should give a is equal to 1. That means the mod value of a will be root over of 2 by a. So if we consider a is an pure real number, that means then fx can be written as root over 2 by a sine n pi by x by a. Now let us calculate the expectation value of x. What will be the expectation value of x at this step? That will be n x n. Again let us use the property of completeness property, that will be minus infinity to plus infinity dx prime in x prime and integration minus infinity to plus infinity x dx double prime x double prime x double prime n. That means x operate on dx double prime will give x double prime, since this is the eigengates of the x. So minus infinity to plus infinity dx prime dx double prime in x prime x operate on x double prime, it is give x double prime minus infinity to plus infinity dx prime dx double prime in x prime, this will give x double prime x prime x double prime x prime in. And since we know these eigengates are orthonormal, that means this will be delta function, that means minus infinity to plus infinity dx double prime in x prime x double prime delta x minus x prime, this is x double prime in, that is equal to minus infinity to plus infinity dx prime in x prime x prime x prime n. Now if we change the variable x prime to x, we can write it as minus infinity to plus infinity dx, since this is the complex part of the complex conjugate of the complex conjugate of the x star n, and which is actually wave function fx, that means f star x x fx. So if we calculate it, we will get, and since fx is only non-zero between 0 to a, that means this integration will be dx, a value of fx is a square sine n pi x by a, its square into x. So let us calculate the value. So that means a square by 2 0 to a dx x into 1 minus cos 2n pi x by a. So first we will get a square by 2 0 to a dx x minus 0 to a x cos 2n pi x by a. It will be a square by 2 into, from here we will get again a square by 2 x square by 2 x square by 2 minus, let us integrate it, x sine 2n pi x by a, we integrate it by parts, it will give pi 2n pi a 0 to a, which will be 0 at a, this function is 0, at 0 this function is 0, that means this is 0, minus plus, that will be a by 2n pi 0 to a differentiation of x and integration of this function, which will give a by 2n pi, there will be a minus cos 2n pi x by a dx, and this is 1, and integration of 0 to a cos 2n pi x will be 0, so that means this will be 0 and this will be 0, so that means this actually is a square by 2 into a square by 2, and we know that what is the value of a square, it is 2 by a into half into a square by 2. That means the value of expectation of x will be a by 2. And let us calculate the expectation value of x square in that state. Let us calculate that. So, and similar from the similar result that we calculated here, expectation value of this can be written as integration of dx f star x dx fx. Similar from this similar calculation, we can write the expectation value of x square is nothing but minus 0 to a, since the wave function is only valid with only non-zero between 0 to a. That means f star x square fx, that is mod a square, that means a square 0 to a dx x square sine square in pi x by a, means mod a square by 2 0 to a dx x square 1 minus cos 2n pi x by a. That means mod a square by 2, this will be, first term will be aq by 3 minus second term will be integration 0 to a x square cos 2n pi x by a dx. Let us calculate these by parts. So mod a square by 2 aq by 3 minus that will be x square sine 2n pi x by a by 2n pi by a, which is actually 0 at a this is 0 and at 0 this is 0, so this will be 0 and there will be plus 0 to a, differentiation of this will give 2x, integration of this will give a by 2n pi cos, means sine 2n pi x by a dx mod a square by 2 aq by 3, this will be 0, that means plus first 2x a by 2n pi minus a by 2n pi cos 2n pi x by a 0 to a. This function will not be 0, and again minus 0 to a, this will be 2, differentiation of x will be 1, and a by 2n pi its square into minus cos of 2n pi x by a dx. This integration again, this integration is only integration of cos 2n pi x by a, which will be 0, and that means it will be a square by 2 aq by 3 minus at 0 it is actually 0, x equal to 0 at 0, but at a it is not 0, which is 2 a into a square by 4n square pi square, and this value is cos 2n pi means 1, that is 1. So that is mod a square by 2 aq by 3 minus a cube by 2 n square pi square. Now let us put the value of mod square, which is 2 by a half to a cube by 3 minus a cube by 2 n square pi square, which is actually, if we common a square, 1 by 3 minus 1 by 2 n square pi square. So what is the dispersion? Delta x square is expectation, which will be a square 1 by 3 minus 1 by 2 n square pi square minus the expectation value of x square. The expectation value of x is nothing but a by 2, that means minus a square by 4, that means a square 1 by 12 minus 1 by 2 n square pi square. So that is the dispersion of delta x square. Now let us calculate the dispersion of delta p. That dispersion of p, that means we have to calculate p's expectation of p. Let us first calculate that. So, and from the similar argument that the expectation value of x means 0 to a dx n x into sine square n pi x by a, from the similar argument we also get that expectation of p will be mod a square 0 to a dx f of f star x and del x sine, sorry, let us write it here clearly. It will be minus I h cut 0 to a dx f of x del x f of x. This is star. So how I will get this? It is let us see that how this can be written as p n p. So this is equivalent to minus infinity to plus infinity to integration dx dx prime in x p n. There will be no need of two integration, only one integration is enough. So from the completed relation of the Poisson kits, we can write this, and this means, and from our previous lecture of the representation of momentum in Poisson kits, we know this relation. That means this is nothing but the dx x n star, that is the complex conjugate of the eigenfunction, and this is minus I h cut del x x n, and x n is eigenfunction. That means here we can write in this problem, this will be expectation will be minus infinity to plus infinity dx f star x minus I h cut del x f of x. And since we know that fx is only non-zero between 0 to 1, this integration means here this integration is 0 to a dx f star x, and since fx is only a function of x, that means this partial derivative is actually derivative fx. Now let us calculate the expectation value of p in this state, that is minus I h cut mod h square 0 to a dx sine n pi x by a, and ddx of sine will be cos, and n pi by a cos n pi x by a. That will give minus I h cut mod h square n pi by a 0 to a tx sine n pi x by a cos n pi x by a. That is minus I h cut square n pi by 2a. That will be 0 to a dx sine 2n pi x by a, and the integration will be 0, since this will give cos 2n pi x by a 0 to a. At a the cos 2n pi is 1, and at 0 cos 0 is 0, so 1 minus 1, this means cos 2n pi minus cos 0. Since cos 2n pi means 1, cos 0 means 1, that means 0, this integration will be 0. So expectation value of p is actually 0. Now let us calculate the expectation value of p square. So, and from the similar argument, we actually, the expectation value of p square will be from the similar argument, it will be 0 to a dx f star x minus I h cut square del to del x to f of x, and that is minus h cut square 0 to a dx sine n pi x by a into the double derivative. The sign will be a by n pi its square into minus sine n pi by x a. They're actually h cut square. So h cut square, this will be n pi by a, so that h cut square n square pi square by a square into 0 to a dx sine square n pi x by a, and that will be h cut square n square pi square by a square into 1 by 2 0 to a dx. 2 sine square x means 1 minus cos 2n pi x by a. So that means this integration h cut square n square h cut square pi square by 2 a square. The first term will give a, and the integration 0 to a cos 2n pi x by a dx. Actually this integration will give sine 2n pi x by a, which a by 2n pi in front, but 0 to a, at a the sign is 0, at 0 this is also 0, this means 0, this function is 0. That means we will give n square h cut square pi square by 2 a square into a. Here one thing we have missed, there will be also mod a square. So everywhere there is a mod a square. So here also there also a mod a square, which will be n square h cut square pi square 2 a square a into 2 by a. That means it is n square h cut square pi square by a square. Now this result we can write directly from this, since this is a state of energy eigencase, and energy, what is the energy, what is the value of, what is the Hamiltonian here? Hamiltonian is p square by t 2m, p square by 2m means if the energy eigenkate is a eigenkates of the p square by 2m, that means it's also eigenkates of p square, and if it p square, that means it will give 2m into energy eigenkates en, and we know that energy En, from here we know that energy is n square h cut square pi square by 2m square, that means it will give 2m n square h cut square pi square by 2m a square, so that will be n square h cut square pi square a square. So we get right thing. Now then dispersion of, what is the dispersion? Dispersion will be h square, that will be, since this is 0, this is means n square h cut square pi square by a square. So what is the uncertainty will be? Uncertainty will be delta x its square, its expectation, multiply by delta p its square, its multiplication, that is delta x square is a square 1 by 12, a square 1 by 12 minus a square 1 by 12 minus 1 by 2 n square pi square, 1 by 2 n square pi square into n square h cut square pi square by a square. That means the uncertainty delta x square will be n square h cut square pi square by 12 minus pi square h cut square, sorry, there will be no pi square, so n square pi square is h cut square by 2. So that means n h cut square into n square pi square by 12 minus half, and evaluate the value. In question it is asked, they evaluate the value of the uncertainty product. So uncertainty product will be this, that this will be maximum when this term will be maximum, that is corresponding to n equal to 1. This will be minimum, sorry, this uncertainty will be minimum when this value, what is the minimum uncertainty? Let us calculate the minimum uncertainty. So minimum uncertainty corresponding to n equal to 1, let us calculate that. H cut square pi square by 12 minus half. What it is? Pi square means 3. Pi square means 3.14. Let us calculate, suppose it's 3, that means 3 means 9 by 12, that actually equivalent to pi square by, that means pi square by 12 is equivalent to 9 by 3, that means 3 by 4 minus half. What it is? It is 4, 6 minus 1, 6 minus 6, oh sorry, this 3 minus 2, this 3 minus 2 is 1 by 4. It's nearly, it is greater than 1 by 4, that means h cut square, this relation is, since this will be h cut square into pi square by 12 minus half will be greater than, not equal, it is greater than h cut square by 4. So let us, and we know that x p its value will be I h cut. Then from uncertainty relation we know that delta x its square and delta p its square should greater than equal to h cut square by 4. Now where the minimum uncertainty, the uncertainty will be always when the minimum uncertainty also follows this relation, strictly follow this relation. Since we know that minimum uncertainty is h cut square pi square by 12 minus half, which is actually greater than equal to h cut square by 4. That means the minimum uncertainty also follows the uncertainty relation. And if we and other minimum, if we check the other than minimum uncertainty, it actually also follows this uncertainty relation. So we have proved, we have solved the question 21. Now we will solve the question number 22. It is an interesting question. In this question it is asked, estimate the rough order of magnitude of the length of the time that an ice peak can be balanced on its point if the only limitation is that set by the Heisenberg uncertainty principle. Assume that the point is sharp and that the point and the surface on which it rests are hard. You may make approximations which do not alter the general order magnitude of the result. Assume reasonable values of the dimensions and the weight of the ice peaks. Obtain an approximate numerical result and express it in seconds. So let us do this. So at first, suppose the ice peak ice peak has a mass m and it is supported by a length L which doesn't contain any mass. Now if it deviates from here to an angle theta, then a torque will be applied on this deviated ice peak, which will be mg. Mg cross this vector will give, that means the torque on the system will be m L square d2 theta dt2 will be mg sine theta. Now mg sine theta into L, mgl sine theta. Now if theta is very small, then this will be L square d theta dt square can be written as my plus mg L theta. M will be not there, and that means d2 theta dt2 will be equal to g by L theta. Now if we solve this equation, this differential equation, what we will get? Let us check. If we solve this equation, we will get theta is equal to some constant a e to the power root over g L t plus b e to the power root over g minus L by t. Now at first let us calculate the uncertainty. The uncertainty at t equal to 0. So what is the Poisson uncertainty? That uncertainty delta x will be theta into L. That means this delta x. So theta into x, L theta, which will be L a plus b. Let us calculate the momentum uncertainty. Delta p is equal to L into d theta dt, that is at t equal to 0, that means it will give root over of root g by l e to the power root over of a g by l t minus b root over of g by l e to the power minus root over g by l t at t equal to 0, at t equal to 0, which will give l root over g by l a minus b. Now what will be the delta x, delta p, and if we assume this is like a Gaussian wave packet, that means the uncertainty is minimum, that means delta x delta p should equal to h by 2, h cut by 2, that means l square g, there is a mass, p is m, there is a mass, there is a mass, so there is a mass m, so that is l square, that means that is right clearly here, that is delta x means l a plus b, and it is delta p is mass l root over g by l a minus b should equal to h cut by 2, that means m l square root over g by l a square minus b square is equal to h cut by 2, that means m g l q to the power half a square minus b square is equal to h cut by 2, that means a square is equal to b square plus h cut by 2m g l q to the power half. So we can calculate the value a and b from this relation, but let us see the relation of theta. Theta will be a e to the power g by lt plus b e to the power minus root over g by lt. This term can be neglected when t much greater than root over l by g. If we want to work tf is in the order of this t root over lg, then this term will no meaning, that means we can set b equal to 0, that means that, and on that limit we can write a equal to root over h cut by 2m glq half. It write clearly here, h cut by 2m glq per half. Now if we put the value here, theta will be a, that means h cut by 2m glq to the power half e to the power plus root over g by l into t, root over g by l into g by l into t. And when let us assume that the noticeable change in the theta is equal to pi by 100. If theta is that much, then we can notice this, the deviation of theta. That means suppose that at t equal to tf, this change we can be notified due to the Heisenberg uncertainty. So then calculate the value at TF when we can see this noticeable deviation because of uncertainty Heisenberg's. So this will be pi by 100 is equal to root over h cut by 2m g LQ to the power half e to the power plus root over GL t, that is e to the power root over G by LT is root over of 2m GLQ to the power half by h cut into pi by 100. So T will be root L by G TF into ln pi by 100 plus root over of 2m GLQ half by h cut. Now if we take G equal to if we take G equal to 980 centimeter per second square gravitational acceleration and m equal to 10 semi, m equal to 100 gram and L equal to 10 semi, and then we can calculate TF. It will come as 3.4 seconds. That means TF in the order of 3 seconds. At if we wait 3 seconds, then we can observe. If we wait 3 seconds, we can observe any noticeable deviation of the angle theta. And let us check this TF is larger than root L by G or not. Root L by G is equal to root over 10 by 980, which is actually, it is similarly equal to root over 10 by 1000. That means 1 by 10, that is equal to 0.1. So our assumption that TF in the order of TF, if we observe TF much greater than root over L by G, that we observe larger than this time, we can neglect the second term e to the power minus root L by G t. So that is our argument, is our assumption is reasonable. And here the if we wait TF is 3 seconds, around 3 seconds, we can observe any noticeable deviation of theta. Here the question, the meaning of the question is actually this, that since there is an uncertainty in position and momentum, that means if we want to observe the position of this peak, if when we want to observe the position, its momentum will be uncertain, and due to the uncertainty momentum, it will deviate some amount, and that deviation we can notice if we wait enough. That means if we wait around 3 seconds, we will notice this deviation, and that is the question asked. Hence we have solved the question 22.